from Berry Science Lab, and today I go to teach you about topology. This is the first topology lesson on live, I think. So, I go to teach you about topological spaces. So, I'll go to that right here. Let X be a non-empty set. X's subset is tau if and only if. So what if X's subset is tau if and only if I with two F's is a fancy way of writing if and only if axiom number 1. Axioms are basically rules, but that are unprovable. So, rule number one. X and the empty set and the empty set, we're going to use a symbol called 5, but for the rest of the lesson, I'll call it an empty set. X and an empty set must belong to tau, because that's how my dad says it. Axiom number 2. The union of two groups in tau must belong to tau. And finally, axiom number 3. The intersection of two groups in tau must belong to tau. So now I go to give you 3 examples of what a topological space is and what isn't. So example 1. Let's say X contains A, B, C, D, E, and F. And tau contains, and so this is going to be long, X and the empty set. And we don't close this, we close this at the end. So we are just going to put this X, comma, empty set, and this is A, and this and D. This group must be A, C, and D, and the last group must be B, C, D, E, and F. Now let's check it with all 3 rules. Rule number 1. X and 5 must belong to tau. And that is true. Oh right, there's supposed to be two of those things here. because we close the paragraph, this paragraph later. So let's start with number 1. X in the empty space must belong to Ta. That is correct. Number 2. The union of two groups in T must belong to T itself. Let's say the union of these two. So A, C, D, B, C, D, E, F. So this puts everything together except that you don't put the same things twice. Imagine ADE and BADE. The union of these would be BADE, not BADE, ADE. We don't write the same things twice. So, A, B, C is there 2 times, so we only write it 1 time. D is there 2 times, so we only write it 1 time. E and F. This is sincerely X, which is in Ta. So it satisfies axiom number 1. Axiom number 2. Number 3. The intersection of two groups in Ta must belong to Ta itself. So let's say the intersection of ACD and CD. AC and D intersections with CD. Things that are in common. So the intersection of those two would only be C and D. Okay, now let's go to example 2, topological space, because it satisfies all 3 axioms. Now what about the next example? Okay. So, example 2. X. Let X be A, B, C, D, and E. And let Ta be X and phi, I mean the empty set, sorry, we don't close this paragraph yet. This would be A, this would be, now, let's see if it satisfies the first rule. Of course it does, you can already see that. Let's see if it satisfies the second rule though. Ooh. Number 2, the union, blah, blah. Let's say the union, let X be equal to A, B, C, D, E, and F again. And let Ta be equal to X and phi, I mean the empty space, I'm sorry. No paragraph yet. And now let's look at this. So definitely it has X in the empty set. And X intersection is AF. They definitely have that. ACF and BCDF intersection is ABCDEF, which is X itself. So that is good. But what about the intersections? So let's say the intersections of ACF and BCDF, because you can obviously see the intersection of AF. Wait, no, AF's intersection with A is A. AF's intersection with F is F. What? Okay, you're, okay. So, but what about these two? So let's look at what they have in common. They have C in common, and they have F in common.